Did I spell it wrong? Okay. Ooh. All right, let's start by reviewing a little bit of terminology that you should know. Happy Friday. Any plans this weekend? We're gonna have a birthday party. Ooh, prom soon, right? When's prom? 14th of April. Happy birthday. The 15th of April. Tax day. That's fun. Enjoying. That'd be a great way to celebrate your 15th birthday. You probably should never start a sentence with, well, I would ask you. Like, either ask me or don't tell me that. Awesome. I want to go to prom. I went to prom last year. I asked my husband via Facebook. It's cute. All right, so a circle. Technically, all of this garbage inside the circle is not part of the circle. The circle is the green line only. So a circle is so technically the definition, a circle is the set of all points, here's a new word for you, equidistant. What do you think it means? Equally distant. Yeah, equally distant from one point. And what's this one point called? So this circle is the set of all points equidistant from one point, and that one point right here is called the center. The circle is the set of all points equidistant from one point called the center. Before we define what diameter is, I'd like to define what a chord is. A chord is a line segment. The line segment with two of its endpoints on the circle. The chord is this line segment with the endpoint of the segment on the circle. Now, if you look at my diagram right there, how many chords are on that circle? Two. Which one? A, S, and B, E. So when I name a chord, you name it by the endpoint, or BE. And then in geometry, this AS and BE could mean a lot of different things depending on what you put on top of it. This is a line segment, so I'm just going to put a little line segment on top of it. That's the notation. If you don't put anything on top of it, it's referring to how long the chord is, or the segment is, so you have to put something. Now, a diameter is a specific kind of chord. What's the definition of a diameter? Say it again. Yeah, so refine that. It's the whole length. Zach?
Isn't it the London
Diameter.
diameter?
Diameter
is the complete length through the center to the other end.
That's the key word, right? It's a chord that goes through the what? Center of the circle. Very good. Now, when you name this diameter, so I put C as part of the diameter. and name the diameter. You don't name it BCE, you just name it BE. Now if I call it BE and you call it EB, are those the same thing? Yes. We could decide to make the rule to make sure it's alphabetical, but I think that might confuse you later. So if I say an answer is BE and you reverse it as EB, just know that you're right. All right, so then what's the definition of a radius? We've already used the radius in our volumes unit. So you should know it's half the diameter, good? It's a segment with the end point. So where are the endpoints of the radius? From the center and then on the circle, right? It's a segment with the endpoints that are at the center and then on the circle. So in this case, how many different radii, that's the plural for radius, how many different radii are there that are listed? Technically there's infinitely many, right? They're just not all drawn. The ones that are drawn in this case, there are 3. So they are EE, what else? EB, and EB. Again, the order does not matter. You don't have to put the center first. You can. All right, let's look at example 1. So the first thing I want to do is name this circle. I didn't tell you how. Let's go back up here really quick. If I wanted to name this circle, you name it with, let's put it here, a circle with a dot in the middle, and then name it by its center. So this would be circle C. Okay, if I want to name this circle, it would be called circle L. Name a radius on the circle. Everybody out loud say what are the radius.
Oh, yeah.
Here we go. If I fix the one you said out loud, you get a ticket. Huh. Just kidding. I'm really bad at giving tickets now. I need to get better. Do you like the tickets? Should we keep doing the tickets? Okay. I need to grab your envelopes from you today. So today will be a no ticket day. And then I'll record all of your tickets, take them out, and then I'll give you your envelopes back for the new quarter. Because everything we do from here on out is new quarter. Welcome to quarter 4. We're almost done. Whoop, whoop. I feel like you should be more excited than what you just showed. Welcome to quarter 4. Yeah, I like how that sounded totally fake. You're welcome. All right, now name a chord on the circle. So everybody at the same time say a chord. H-I. H-I. DJ. DJ one? Yep. So H-I, DJ. Those are the 2 chords. Specifically, name a diameter. That one. On the test, if you don't put the appropriate hat on top, I call it a segment hat, the points will be less. Okay, so now we've got some calculations. If GL is 10, what's JL? Well, these are both what? Radius, so they have to be equal. Very good. If JG is 7, so the entire thing is 7, how long is LG? How did you get it? You divided it by 2. Very good. If LK is 4.2, find HL. Okay, so now let's start talking about what an arc is. There are 3 different kinds of arc. There's a minor arc, a major arc, and a semicircle. Before we talk about what an arc is just a piece of the circumference, or part of the circle. An arc is a portion of the circle. The minor arc is that part of the circle. The major arc semicircle. Now technically on this last one, how many different semicircles are there? Both halves of the circle are semicircles. So let's define what they are really quick. How would you define a minor arc?
Lower half.
It's like the smaller piece of the arc, right? I would name this arc AC. And the marking I put over AC, any guesses? It's going to look like an arc, yeah. Yep. It can't be a line because that would be a line segment, so it has to be an arc. Now, arc degree, let me erase this up a little so you can see it. An arc degree, the definition of this is the central angle required that's going to form that arc. Nice. So a central angle is the angle that's stemming off of the center of a circle. And when you have the two radii right here, this is called the intercepted arc. So it's the piece of the arc that those two radii will intersect, right? The central angle is the angle that the two radii form. So in this case, the arc degree. So the notation for that is the measure of the arc is 110 degrees. So the little m, when you see the little m in front of things, you've seen it in front of angles before. That's just the measure of the angle. Any questions with that one? If I'm talking about the major arc is going around the circle. I would name that arc. Now I can't call it DF because if I called it DF, it would go straight from D to F. So what's another way I can name it? DEF. So I need to put another letter in there, another point in there, so I know to go around the circle. Now if you take your circle and you spin all the way around, what degree change is that? Okay, like you do on skateboards, right? Or like 360. So if this entire circle is 360 and I take off 60 of it, what would the rest be? 300. So the measure of arc DEF is 300. Now with this last one, a semicircle is half of the circle, right? So technically I have two semicircles here. If I wanted to name the yellow one, how would I name it? KL. And what's the measure of a semicircle? 180. Half of 360 because it's half of the circle. And isn't this a line right here? What's the measure of a line? 180, right? There it should be. Any questions so far? Okay. We've already discussed what a central angle is. The central angle is the angle formed of two radii. And you could have more than one central angle depending on where the central angles are. This right here is one central angle. This right here, is another central angle. Is it possible to add these two angles together? Can you add angles together? Yeah? So I can. And when I do, what would I get? CSR. So you have a bunch of potential angles. It is possible to add or subtract them. So let's practice that. I believe on yours, can't find us. You have these arcs, right? I couldn't figure out how to do it on. Okay, in circle S. In circle S, measure angle DSA. DSA is 50 degrees. And CF is perpendicular with SB. What does that mean? CF is perpendicular with SB. That means it forms what kind of an angle? A right angle. Now that was marked for you. It didn't have to be because they showed you right here. So what degree measures a right angle? 90. Good. I want you to find each measure. So let me point out one more thing. Maybe right here. The measure of angle DSA is the same. So DSA is right here, right? 50. It's the same thing as the measure of arc AB. Because the definition is the measure of the arc is the same thing as the angle required to make arc. So if I wanted to find the measure of EA, EA is right here, right? I would first start by finding the measure of this angle. Any ideas of how we would go about doing that? Zach?
Well, that's one for line E to E. That's going straight through the middle, so we know that that's split by 180. We know that DA right there is a 50.
Okay.
And we just have to subtract 50 from 180 degrees.
Perfect. And we get 130. So this angle is 130, which means the arc is 130. That's two different ways to say the same thing. Okay, what about arc CD? CD is this little guy right here. Any ideas on this one? Somebody knows? Aaron?
It would be 40
and you have your diameter again right here, right? Very good. So this guy is 40. Alright, and the next one, find the measure of arc ACE. So I start at A, I go through C, and all the way back down to E. On your own, see if you can figure that out. What's the arc of ACE or ACE? Any ideas? 230? How did you get 230?
I said,
By the way, that's not the way I would have done it. That's totally fine. There's about 4 different ways to do this. Perfect. So we already figured out this was 130, right? Subtract the 130. That's actually a lot easier than the way I would have done it. You said 230? Very good. Somebody else can figure out this more than one way. Erin, what did you do?
I already used the, like, so, I didn't do that ABCD when, like, was funny. So then I just added 50 to that because it was, like,
How do you know that's 50?
because 50 plus 130.
No one knew. Good. Anybody else? Anybody else have another reason why this is 50? Brooklyn? Okay. Natalie? Makes me so happy. This is the way I would have done it. Not that your way didn't make me happy. I'm just so proud that you remember this word. Yes, vertical. So these are what? Vertical angles, and what do we know about vertical? They're congruent. So there's a lot of different ways to go about the same task, right? Good job, guys. All right, now that this is a complete mess. Slightly bigger. Okay, let's do the last one. Find an arc that is congruent with arc AD. So what arc is congruent with arc AD? What is it again? BE. I know those are congruent because again, what Natalie said, this angle right here and that angle right there, they're related because they are vertical. And if they are vertical, then their arcs will be the same. Okay, let's try a few more. Feel good about this. Find the arc measure or indicated or angle indicated. So if this is 112 degrees, what is this arc measure? 112 degrees. If arc UT is 61, find the measure of VWU. VWU. Why?
So DC, the diameter is
Diameter is subtracted 61. Very good. And if this arc is 119, then that angle is 119. Okay? Okay, let's do another one. If this is 130, this arc would be what? 130. Good. I forgot the degrees. Put the degrees on there. Arc FDE. FDE. So F. One giant mistake is you're used to going straight from F to D. Make sure that you remember this is an arc. So a mistake would be going straight there and then going around. That's confusing. So F, D, E. How would you do this one? Raise your hand if you have an idea. Andrew?
So you know the FD is what we on 95 of that.
Let me give you a really quick pointer. If there's ever a dot right here, it usually indicates that that's the center, so you know for sure that that's the 180. Very good. So this is 180, that's the 95 together. They make? Great. Part E. Part E. What are you looking at this one? Angle FHE. Now it's showing us some variables, not just numbers. Well, one was 110, the other one was 110, right? What do you do when there's variables involved? Panic, cry, calculate.
Give up.
Hey, be honest, after you panic and cry, then what do you do? Okay. Oh, good idea to know. They're equal to each other. Good. These two are equal. I know that you're not supposed to say that. These two are equal to each other, right? They were 12. These two are equal to each other. You just have to be strategic on how you set them equal to each other. Now, you have to pay attention to what the question is asking. Is the question saying find x? So, if the question said find x, it would solve, it would be done. But it doesn't. It says find the angle. So once we find x, what do we do? Yeah, minus 9x. Can I add this one at the same time so I don't have to keep rewriting things? So it equals 12. So x equals 6. This is not my final answer. Now I'm trying to find the angle FE or FHE. Does it matter which one you plug it into?
No.
No, because they're the same. Actually, probably easier to plug it in there. 66 minus 1. Good, good. What about this one? Measure of arc JK, which is here. What I do is you have to solve this one. Raise your hand as soon as you got an idea. Natalie? Why would you add them together when they're equal to 360?
Because, 360 is how the degree of curve is. Because of that.
Oh, this is making my teacher not happy. Yes, let's add them all together, set it equal to 360. That's perfect. The entire circle is 360. So when we add them together, you have a negative 17, a negative 8, and a positive 1 would combine to make a negative 24x. And then will somebody add those together for me? Equals 1 on 4. Somebody confirm, please set my hand. Okay, now you can solve the equation, plug it in when you're done. So subtract the 144. 36. Divide by, ooh, we're going to get a decimal. Not too ugly though, right? Negative 1.5. Is it just 1.45 or is it negative? I think it's negative, right? Lucky child. We all get a point, so we're not getting points today. We all get a free homework question. So I can cross off one of the problems you don't want to do in homework.
Oh yeah, why didn't we set it to a 360?
Because your teacher has not used the number 360 for a really long time. Leave me alone. Get a free homework question. No, I'm just kidding. Yeah, perfect. Good job, guys. Scratch this recording. Okay, what is that? 216. Now let's divide by a negative 24. Do we get a whole number this time? X equals 9, negative 9. Relax, and we knew that 5 minutes ago. So if I'm trying to find arc JK, I take that negative 9. Now with geometry, I always get kind of nervous when I see negatives. X can be negative, the arc cannot be negative. Is that okay? So because I'm talking about an actual circle, plug this in, do I get something negative? Plug that in, I'm going to get 72 plus the 13, which would equal. Right, click off from this page. Next page. How many more pages do we have? Great. Is your next page after that page 2.2 as well?
Yeah.
That's alright. Okay, now we're going to talk about inscribed angles. Remember this one right here? What was this called? Everyone? What kind of angle was that called? Like the top of the other one. That's okay. This angle itself. Look back at the angle and look this up. Hard to see. That's called a central angle. How do you remember this one's the central angle? Because it starts from the center, right? It's the central angle. If it doesn't go from the exact center, it's not a central angle. So this right here would not be a central angle because it's not in the center. This angle is called an inscribed angle. I don't know if you have any way to remember that. The definition of an inscribed angle would be what? An angle formed by two chords. I'm not sure I've ever described it before, but I like it. You know what? You know what? It's Friday. You don't get a free test question for that one. No, the homework question.
It's been a long day.
Just kidding. I'm having a great time. So the rule is, now remember, if this was the central angle and this was 80 degrees, this guy right here would be what angle measurement? It doesn't look like an 80, but this would be what? 80. Because the central angle and that arc measurement are the same, right? The inscribed angle, angle B right here, would be 40. So knowing that, can you come up with a rule? The inscribed angle, when I was in college, I learned this for the first time because I never took geometry in high school because I skipped it. Not because I'm smart, but because I moved a lot and everybody hated geometry, and so I was scared to take it because everybody hated it. So I never took it. So I learned this for the first time in my modern geometry class. They called it the Star Trek theorem. Why? Okay, so the inscribed angle is what again compared to the central? It's half. Yep. 1, I was in a Granite School District, and their order was alcohol and 1 to alcohol 2. And then I got remarried, and I moved to the Salt Lake School District, and their order was alcohol 1, alcohol 2, and then to alcohol 2. And I stepped into alcohol 1, so I went to alcohol 2. And I moved to the Southern School District, and their order was again alcohol 1 to alcohol 1 to alcohol 2. I just finished alcohol 2. And so I smiled, and it was a calculus, because it was a question. So, this right here is a special case of an inscribed angle. This is what? A diameter. So the diameter, what's the degree measure of the diameter? 180. That means this right here, the inscribed angle would be what? 90, because what's the rule again? The inscribed is half. So, I don't know if there's a real definition for that one, but if the central angle is the diameter, then what? Then the inscribed, or then the, angle is the right angle. Now, what kind of triangle did that just form? And what kind of things do you know about right triangles? What kind of things can you do with right triangles? Many things. Specifically, we might have some Pythagorean theorem questions. I don't think we will. We should. We could have trig questions. Because if you have a right triangle, can you use trig to find missing sides, missing angles, missing pieces? Yes. Could you use Pythagorean theorems to find missing sides, missing angles, missing pieces? Maybe not angles, but the pieces, yeah. So you may want to be looking for those when you have a diameter. All right, let's try a few examples of those. So given some inscribed angles, I want you to find missing arcs or missing angles. So this right here is the inscribed angle. This is how I like to do these problems. I like to take the inscribed angle and find the central angle. So now this is always still, I don't want to say funny, because it's really not too sad when you miss a question. Look at it. This is 69. You say this is twice as big or half as big? Now you can't always trust the picture, but can it help guide you? So that looks bigger, right? So if you don't remember, that's the picture on this one. Double it, what can we get? 138. Now if that central angle is 138, what's the arc? 138. So I would feel really bad when I take that inside angle and then half it, and I see everything on both like half. Okay, this right here is a central angle. We don't know what it is. This is the, or sorry, just saying, that's the inscribed angle. We don't know what it is. This is the central. If the arc is 174, what's the central angle? 174, because the arc and the central angle are the same. And then if the central angle is 174, can you find the inscribed? Yes, what would it be? That's how you go about doing this problem. Could you skip straight from the arc to the angle? Yes. If you feel comfortable doing that. Okay. What about part C? There's going to be a little bit more manipulation on part C. Please try it. Not quite as triangle up. What do you notice about the triangle? What is S? What is DS? What is DS? It's the diameter, right? 180? How's that dangerous? You can see there's more than one way to do this problem as well.
Well, since, VX, so there, that's 180, and then since, VWX is 50, we know that the arc above,
hold on, VWX, WX, this one is 50?
yeah,
Sorry.
so we know that
VWX?
the arc above that right there is also 50.
Well, it's not right.
What am I saying?
Is this a central angle or is it an inscribed angle? It's inscribed, so you got to double it. So this is 100.
Keep talking now. You have the right idea. So let's carry on now. Now that you've seen that that's 100, that's not the arc we're looking for. I want somebody to take Zach's idea and roll with it. What do we do next? Harrison?
Well, because it's along the diameter, that would be 100 out of 180, so there's 80 left over.
Question.
Perfect. Good. Questions? So you may have to manipulate the circle a little bit to help you find the missing arc. Let's do that again. I'm trying to find this angle right here. I know this is 67, this is 95. Okay, so not anymore. Ideas. What do you know? What do you need? So if we're going to start by adding this together, what purpose does that solve? Sound better? You can use it to find it. So let's just start by adding this. What's 95 plus 67? This arc right here is 162. Okay, somebody new. Where do we go from there? Right here? That would be 198. So this 198 is this part, right? Now this angle opens up to that arc. Is the angle half as big as the arc, or is it equal to the arc? Is this a central angle, or is it an inscribed angle? It's inscribed, so it's half, right? We're going to take this guy, divide it by 2. We get what? 99 degrees. Done. Questions on that guy? Is that it? Oh, good, because I'd feel really bad if we were done. Just like this stuff. All right, thoughts on this one? We're done super early. You also have your homework finished before we leave class, right? We're going to have more than a half hour. Okay, now I've got variables. Find the measure of angle MKL. This is this one right here. So anytime you start a problem, what are you given? What do you know? We got some variables, so after we're done trying and inserting our fixes over some of the letters, now what? Combine them. Why do we combine them? Close, but with variables, right, Leslie?
So we kind of looked at say 21x plus 9 because the arc of
So this right here, oh, that's not even hold on. This arc right here is half of this angle, right? So do you have a number that is going to go along that arc? So we probably should start by adding them together. We've got a 13x, hard to tell what it looks like. So 13x to the 21x would make this 34x. Plus 1 plus 9, right? Plus 10. What are we going to set that equal to, though? That's the question. That's kind of the key part. Why would we set it equal to 180? Because this is the diameter. Good. And then do your math solving skills. Subtract from 10. Divide by 34. 5. But that's not the question. The question asks you to find that highlighted angle. So we have to use this 5. Where will we be plugging it into? Here. 21 times 5 is 105 plus 9 is 114. Now or sorry, this angle relates to this arc, is it half as much or is it equal to? How do you know it's half?
Because if you do the times the diameter of the metal, that would be the diameter.
This is central, so this is the 114, right? So this guy is half. So, the inscribed angle is half the central angle, half the arc.